Subscripts, when we're trying to generalize, why do you think that is, that we use subscripts? Why do I write a sub 1, a sub 2, a sub n? That's right, there's not an infinite number of letters. So if you tried to use like a over this, b over this, c over this, then what happens if you have 100 distinct linear factors? What letter are you going to use out there? You see what I'm saying? So when we use subscripts, it allows us to generalize and not ever be limited by our alphabet. That's why a lot of formulas in math look so bad, because we have to generalize. But do you get the idea? Distinct linear factors, constant over linear, constant over linear, constant over linear. The next thing that we can have is repeated linear factors. So every time we see a repeated linear factor, that means it's linear, but it's raised to a power. Then we're going to write out whatever this power is, we're going to have that many fractions. So if we have k of them, we're going to have k fractions. And then what happens is we start with the linear to the first power, linear squared, linear cubed, all the way until we get to the highest power. Does that match what we did earlier? When we had the squared, we did the linear twice. One of them was x minus 1, the other one was x minus 1 squared. Okay, so that's what we do if we have repeated linear factors. And now we get to irreducible quadratics. If we see an irreducible quadratic factor, ours was x squared plus 4. No?
Yeah.
It was x squared plus 4, which is irreducible. It can't factor. Then what we're going to do is we're going to rewrite it as one fraction, but instead of having constant over the quadratic, we're going to have a linear expression. All right, I used bx plus c. Again, the subscript is because we like to generalize. What would happen if you had a repeated quadratic irreducible? We haven't looked at this yet, but it's just an extension of what we already did. If this is irreducible and it's raised to the k, then guess how many of these we're going to have? K fractions. It'll be the quadratic with a linear on top. Then the quadratic squared with the linear on top. Then another quadratic to the third power linear on top until you get all the way down to the bottom, or to the end. That's how you handle irreducible, repeated quadratic factors.
So how would you write? Would you do like ax plus b for the numerator and then...
I'm always going to use letters because we're never going to have a problem where we go beyond.
Yeah, but like, would you do like ax plus b and then
cx plus d, and yeah, and then probably ex. Yeah, yeah. I'm trying to think if I would skip any letters. I'd skip x if I ever got out to x, because I'm already using x. Right. Does this kind of make a little more sense now, reading through this a little bit more? All right, so here's where we were. We were trying to do our completing partial fractions. We had this and x cubed plus, oh no, we had factored out the x. So x times x squared plus 4. And we said that that's going to turn into a over x plus bx plus c over x squared plus 4. And that's where we are, right? So let's go ahead and see if we can knock this one out real quick. I'm going to multiply both sides by the common denominator, which will leave me just this over here. So I've already done the next step, which was I would have the a here with what next to it? The x squared plus 4 would be next to it, right? And then I distributed that through. Then I would have bx plus c, and what would be next to it? X, so I distributed that through and I get that. So I've already done that algebra. Now, let me see if you can keep up with this. This is going to be a plus b x squared plus cx plus 4a. I've grouped the x squareds together. I've grouped the x's together. I only had one x. And I grouped anything without x's together. Can you give me my equations?
two. Oh, wait.
Yeah, let's do the letters first, then I'll do the matrix.
Oh,
A plus B is what? 2. Next one. C is -1. So we're going here to here, -1. There to there. And then this one, 4A is 4. So this would be 4A is 4. Yeah, this one, you already know what 2 of them are, right? So, yes, you could do the matrix on this. I mean, the RREF, couldn't you? To be 100% sure? But look at this equation right here. This 4A equals 4 means that A is 1, right? I already know C is -1. And if I know what A is, then what's the first equation become? If A is 1, then the first equation becomes 1 plus B is 2, right? So B is also 1. So 1, -1, 1. Now, just for the sake of putting it up here, if you were going to do the RREF, it would be 1, 1, 0, 2, 0, 0, 1, -1, and then 4, 0, 0, 4. And then you do your solving, and you should get 1, 1, -1. Right? It's going to be A, B, C. All right. Unfortunately, we are not there yet. Okay, we're not done. All this does is allows us to rewrite it. Any questions? No? I think I'm ready to go back to the integral. May I? Our new integral is A over x. What was A? 1. So 1 over x plus B, which was also 1. So 1 times x, that's x. And then plus C, but what was C? -1 over x squared plus 4 dx. How do you feel about integrating that? How do you feel about integrating the first piece? Because this is 2 terms now, right? 1 over x, we're okay with that, ln x. And then what about the other one? A u sub, if we do u sub right now, what's du going to be? 2x. We have x minus 1, so we're off a little bit, right? Ah, good, that's what I wanted to hear. How about this? The comment was, can you split it? Yep. Everyone see the splitting here? X minus 1 on top, split it into 2 fractions. X over the denominator, the 1 over denominator, and the minus went between. Look at the first one and the second one. You should just be able to look at those and tell me the answer, right? Natural log absolute value of x.
2 ln x squared. 2 ln absolute value. Negative ln.
Arctan.
Oh.
Arctan. Careful. This one's arctan. So this one right here, we're going to have well, all right, I said you should see it. Let's actually, get to that in a second. How about this one, though? This one, just do a basic u sub right now. If u was x squared plus 4, the derivative is 2x dx. And look, you almost have that, don't you? You have x. And so I could scale it. So I go 1/2 du is x dx. And I can take the 1/2 out. So this right here, this integral will turn into integral. I have a half out here. I have 1 over u du, won't I? Use this. So 1 over u, the derivative, du, 1/2, is the x dx. So it'll be 1/2 natural log of this. I'm ready for the answer here. Natural log absolute value of x plus 1/2 natural log x squared plus 4, and then minus 1/2 arctan of x over 2 plus c. Why is it 1/2? A is 2, right? A squared is 4, so A is 2, and then the formula, there it is. This is our last example. I had a student in my other class ask me the question, like, what sort of problems should we expect on the test? And I said that the problems on the test will be in line with what you see either in class or in homework. So I could come up with some crazy problems. I'm sure that would be very difficult, but I'm going to stay within the frame, within the level of difficulty that's consistent with what you're finding in the homework or in class. But remember your test. What's that?
What chapter is the test over here?
I don't even know when the test is, to tell you the truth. I know it's right before spring break?
Yeah, it's Thursday.
So let's see. Today's the 23rd. So we will cover, our test is going to cover basically from trigonometric integrals, like cosine, sine, tangent, secant, all that, trig sub, partial fractions, and then we get to definite integrals, which is, we're going to actually do like talk about why we're doing this, right? And then so that's part of chapter 5, and then 6.6 also, which is improper integrals.
So our test is on the 9th of next month, right?
9th of March is when it's scheduled, which is the Thursday before spring break. Okay? All right, let's take a look here. Let's pass the sign-in sheet around too. Let's do that. Sorry?
I thought you go off the quizzes.
I do go off the quizzes, but sometimes it's better for me to have the signature in case they ever want to come back and they, being the administration, says, were you taking attendance? It's better for me to have initials than it is for me to just have check marks. All right, what do you see here? Long division. Everyone see long division? If they have the same numerator and denominator, powers. Now, so look, you can do long division with this, right? Yes? I'm going to show you something, though, that's kind of tricky but kind of cool, just so you can see it. Is this not the same as 4x squared minus 4x plus 3 over 4x squared minus 4x plus 3? Isn't that the same? No, that's not the same, right? But if I did plus x and minus 1, it would be the same, right? I know that looks weird, but I just looked at this and said, look, the denominator looks awfully familiar to the numerator. They're just off a little bit on the x terms in the